Today we're going to cover multiplication with zero pairs. We're going to cover two rules today, but before we get into the rules, quick note about multiplication. Starting now, we're not going to use the traditional x to show multiplication anymore. The reason why is because when you get into algebra, x is going to be used as a variable in a lot of different equations. So we're going to show multiplication most of the time using parentheses. So you're going to have your two factors. One factor will be in parentheses. This indicates multiplication. I would read this as 3 times 5 or 3 groups of 5. You may also see dots used for multiplication at this level as well. So the first rule we are going to cover is when the first factor is positive, create that many groups of the second factor. So here I have the problem 3 times 5, which I can also read as 3 groups of 5. So I can use my counters to create that. I need 1, 2, 3 groups of 5, and when I combine them I find that 3 times 5 equals 15. The same rule is true even if the second factor is negative. So here I have 4 times negative 10, or 4 groups of negative 10. So my first factor is positive, so I'm going to create that many groups of my second factor. So I need 4 groups of negative 10, 10, 20, 30, 40, and that's negative 40. So 4 times negative 10 equals negative 40. All right, so here's the second rule. When the first factor is negative, remove that many groups of the second factor. So this negative symbol here in front of the first factor is kind of making an opposite rule. Instead of creating, we're now going to remove. The problem is I've got nothing here to work with. So how could I possibly remove anything? Remember back to the lesson in subtraction. You can add as many zero pairs as you want to any equation or to your work area right here, and it will not change the value because this zero pair cancels out. So it's like adding 0 to the surface. We're going to need to use that principle in order to solve this problem. So this problem is telling me to remove 3 groups of 2. So I'm going to have to add 3 groups of 2 zero pairs to my surface. So here's 1, 2. Here's my first group. Here's my second group. And here's my third group. So now I've got 3 groups of 2 zero pairs in my work area. And I need to remove 3 groups of positive 2. So I'm going to take away one group. Here's my second group. And this is my third group. Then I take a look what I have left. I have 6 negative 1s. So negative 3 times 2 equals negative 6. Next problem, I've got negative 5 times negative 5. This tells me to remove 5 groups of negative 5. So again, I need to add some zero pairs to my field in order to be able to remove 5 groups of negative 5. So I'm going to create a field of 0 pairs, all consisting of groups of 5. So first group, second group, here's my third group, fourth group, and fifth group. Now I need to remove 5 groups of negative 5. So I'm going to take away 1, 2, 3, 4, 5 groups of negative 5. I combine what I have left. 5, 10, 15, 20, 25. And negative 5 times negative 5 equals positive 25. So a quick recap of the rules. When the first factor is positive, create that many groups of the second factor. And when the first factor is negative, remove that many groups of the second factor. Now in reality, we understand you're not going to be using the counters to be doing your multiplication with integers. We use this model to show you why it works, so you understand the mathematical principles behind it. The more you do, you're going to see a pattern. When you're multiplying 2 positive numbers, the answer will always be positive. When you're multiplying 2 negative numbers, the answer will also always be positive. So when you're multiplying the same signs, both factors are positive or both factors are negative, the answer will always be positive. When you multiply a positive by a negative number, your answer will always be negative. And when you multiply a negative by a positive factor, the answer will also always be negative. Different signs equal negative.